Now which one has the coin? Oh, this one. Well, let me help you a little. The coin isn't here. Well, give me a second. Stay or switch? I'm staying. Well, unfortunately... What? How would you know that? Wait, let me explain that one. If it was a human brain, he would do this mathematics instead. At first, when he chooses a cup randomly, his cup has 1/3 chance of being correct. That means the other 2/3 chance is spread across the two he didn't pick. Then, when an incorrect cup is removed, the whole 2/3 probability gets concentrated on the other unopened cup. But since it was AI, this is how you knew instead. AI has a neural network as its decision-making system that mimics your brain. It consists of layers of nodes and their connections. Input layers solve purposes passing the raw data to the next layer. Middle layers are like a big unknown box, so they are called the hidden layers. And the last layer, each neuron representing the possible results, is where the output is shown. The network flows neuron by neuron through the hidden layers. All the middle neurons each have their inputs from the previous layer, bias, which are the base value if the inputs are 0, weights, which are numbers that scale the importance of each input, and activation functions that decide how much signal actually gets passed forward onto the next layer. Each neuron multiplies their inputs by the input's weights, adds a bias, passes it through an activation function, and sends a signal forward. And when the network's finished, it gets it wrong. Yeah, wasn't it supposed to be 2/3 the other cup? Well, because it's not trained yet. Actually, the weights and biases are set as random values at first. Then it measures how far from the actual result its output is, and we call it the cost. In order to minimize it, the network calculates how each weights and bias affect the cost by taking partial derivatives of the cost function in terms of each weights and bias. Using these gradients as a guidance, it adjusts the values repeatedly until it gets an acceptably accurate result. So what the network actually does is, it invents a new parameter configuration that when passed through the functions of the middle neurons happen to spit out numbers that are very close to the actual maths.